Welcome to the Open School, a school where teachers all around the world help students all around the world. The distance between the Earth and the Sun is 1.5 10 to the 11 meters. Calculate the light intensity received on Earth. So the intensity is the power divided by 4 pi d squared. So in our case, 3.9 by 10 to the 26 divided by 4 pi multiplied by the distance from the Earth to the Sun, which is the radius of the sphere around the Sun, and the Earth is on this sphere, on the surface of this sphere. So it gives you 1.5 10 to the 11 and the whole thing squared. Right, so let's type this in our calculator. I will go back onto the main screen. Right, ready. So 3.9 x26 divided, and then I'm going to put some brackets because there's lots of stuff under here. 4 multiplied by pi, so shift x, where there's pi, you see on the top there's a little symbol. When you press shift and then you press the button, you get the symbol on the top if you press shift before. Then multiplied by 1.5 x 11. But remember, when I put the e like this, it's like putting some brackets. So I can directly put the square. And the square will only apply on this part. And here we go. I find 1,379, or about 1,380 unit watts per meter square. This is called the solar constant. It's actually got a name, this number. It's called S, the solar constant. So I'm going to add an exercise and an extra question. First, I need to go on the internet to check what is the distance from the Sun to Mars. So I'm typing on the internet. The distance from the Sun to Mars, so I can draw, Mars is another planet which is behind us, it's a bit further. Here we've got Mars. The distance between Mars and the Sun is 228 million kilometers. So that's 228 by 10 to the 6 kilometers. I need to put this in meters. So 228 by 10 to the 6 by 10 to the 3, because this is a K of kilometers, meters. That gives me, if I calculate this, 2.28. Oh, I can put 228 is 2.28 by 10 to the 2, by 10 to the 6, by 10 to the 3. So give me 2.28, 2 plus 6 plus 3, 10 to the 11 meters. Right? So I've got the distance between Mars and the Sun, 2.28 by 10 to the 11 meters. Could you calculate the solar constant for Mars? So for this, it will be I equals the power of the Sun divided by 4 pi d squared. Could you calculate it? Pause the video. Right, so 3.9 by 10 to the 26, that's the power of the Sun, divided by 4 pi, and the distance between Mars and the Sun is 2.28 by 10 to the 11, that I squared. So type it on your calculator. Okay. I found, or the solar constant for Mars, I'll find around 600 watts per meter square. Now, 600 watts per meter square is much less as what is received on Earth, which we found something like 1,400. Yes, on Mars, the temperature is much colder than on Earth because Mars receives much less energy. Well, I think I'm going to close on this. I had some more exercises, but I think this is enough. If we continue, probably the next lesson, we will continue a bit on this. We will look at the stars themselves, the stars in the sky. These are also punctual sources of light, like our sun. And we actually receive energy from the sun. But you will see that this energy is very, very small. When you look at the sun with your eyes, it burns your eyes, you know, it's very luminous. If you look at the stars, well, it doesn't burn your eyes because they're very, very dim. It's because the stars are very, very far. If D is very, very large, the intensity will be very small. Therefore, this is why they appear very small. Okay, I wish you have a nice 2 weeks. I will see you in 2 weeks. And, well, bye.